Welcome everyone to the Big Data and AI webinar series. As always, we hope that you are safe and you're well, and we thank all of you for attending today's session. As always, new webinars are hosted every Thursday where we discuss strategies, solutions, emerging technologies in the data and AI space and help to educate and advance the industry. So today we'll be focusing on successful data platform designing a platform. Our speakers today will showcase 3 different solutions for your data platform needs. Our lineup of speakers today are Lorenzo Danesi, who's the solutions engineer at Yellowbrick, followed by DeMers, CEO at Cinchy, and Rob Hedgpeth, director of developer relations at MariaDB. All questions will be answered at the end of every presentation. We ask that you put your questions in the Q&A tab that's located on the right-hand side and not in the chat. If you put your questions in the chat, we may not see them and we therefore may not address them. Any questions we aren't able to get to, we will submit to speakers after the webinar has concluded, and they will have the option to answer your questions and we will send them out to the audience. We will be taking no breaks on today's webinars, but the webinar is recorded. So if you do have to step away, don't worry about that, because a link with the recording will be sent to all audience members, along with any slides that presenters agree to have distributed after the webinar has concluded. These should arrive early next week. So without further ado, we will get started in today's webinar, and we're going to be starting with Lorenzo. Hi, Lorenzo.
Hi.
How are you today?
I'm good. How are you?
I'm well. So there are your slides, and you can get going.
Okay, thank you. Hello, everyone. My name is Lorenzo Danesi, and I'm a systems engineer at Yellowbrick Data. And the topic of this presentation is how to drive value from your data lake. And by the end, I hope you'll have some ideas to help you make the most out of your data lake investment. So please follow us at Yellowbrick Data on Twitter, and please remember to use hashtag YBLive to participate and retweet. So databases and the MPP data warehouse concept have been around for a long time and started emerging around the 1980s timeframe. So before cloud technology came into the picture, traditional data warehouses were on-premises platforms and fairly expensive to buy and operate. They were mainly transactional systems and were not really meant to process very large volumes of data. They stored and continued to store data mostly in a structured relational format. And over the years, additional data sources started emerging, such as CRM, and ERP systems. So the need for databases to be able to handle larger volumes of data became a necessity. As technology improved, new data warehousing companies emerged, with their appliances claiming a smaller footprint, a lot cheaper and faster with MPP technology, saying that they could process the increasing load. Enter big data. The promise of Hadoop was to replace the data warehouse and be able to store petabytes of data in a centralized manner on HDFS very inexpensively, and be able to map the data with an SQL layer. As companies embraced this new technology, they soon realized that, yes, I can store massive amounts of data very inexpensively, but I need a ton of hardware, an army of people to maintain, and it simply does not perform, and the cost of the investment is skyrocketing. So with that letdown, and as the cloud technology was growing in popularity, data warehouses started emerging in the cloud with Redshift on AWS, SQL Data Warehouse on Azure, and BigQuery on Google. So while they could process SQL and ran in the cloud, they still operated on commodity hardware, and performance degraded as data volume and concurrency or user concurrency grew. Then Snowflake emerged as a strictly cloud data warehouse, also running on commodity hardware and using cheap cloud storage such as AWS S3, and later deployed on other cloud providers. But Snowflake relies on caching data for performance, which means more processing time is required to build and rebuild those caches, which results in unpredictable performance and higher cost to the customer. The latest breakthrough technology is Yellowbrick, and it is the new modern all-flash architected data warehouse, which is uniquely suited for the hybrid cloud. With Yellowbrick, you get the choice of deployment on premises, in the cloud, or a combination of the two. Since it is the exact same hardware in the cloud as on premises, you get predictable performance no matter where you deploy, without the need to cache data. So why did the enterprise adopt the data lake? Well, there was a lot of industry disruption going on about 5 or 6 years ago, revolving around unstructured data from mobile devices, machine sensors, the web, and more. So there was a need to be able to store this unstructured and structured data in one central repository. And as you saw in the previous slide, companies, especially the large ones, had many systems which created duplicated, out-of-sync data silos. So the data lake promise was that it was going to minimize or remove those silos that were within the enterprise. So as enterprises started implementing data lakes and realizing that they could store lots of data in very inexpensively, it led to enterprises wanting to be able to access much more raw and historical data. And there was also an idea that the data lake would provide a repository for ungoverned, unstructured raw data so that you could do the types of queries and get the insights that you needed from your data lake faster. And this occurrence then came to be known as a data swamp. So there have been some myths about the data lake, and some of those myths have driven the adoption of the data lake within the enterprise environment. So over time, people began to see that those myths and realities really didn't line up. One of the myths, and as I mentioned earlier, is that the data lake was meant to be one central repository of truth, and it was intended to store all of the data from all of the different silos. But what enterprises found is that the operational data warehouses were still needed in their environment. And in fact, the data lake did not get rid of the need for those data warehouses. And I'll talk a little bit about this later on. The other myth around data lakes was that existing users would be able to access the data, but soon found that existing users needed to be retrained, and there wasn't enough resources out there that really understood HDFS, Hive, how to implement the data lake, and not to mention the lack of tools and documentation. Then everybody jumped on the bandwagon, and you saw things crop up like Yarn, Zookeeper, Pig, HBase, to name a few, and confuse things even more. Another data lake myth is that it was going to require less management. But what we hear from our customer base is that the data lake has actually high operational overhead from the amount of hardware, developers, and resources, et cetera, that are required to keep it up and running. And due to the lack of data governance, easy data extraction is not easy. In fact, very time-consuming and expensive to implement. So this makes design for interactive applications very difficult to implement, with the big problem of trying to design a data model that works because of the lack of performance. So once the data lake turns into a data swamp, extracting raw data can be a difficult undertaking because it's just one big massive repository of data that enterprises really can't mine. So all that aside, there is still a need for the data lake, and that's with a data warehouse to work in conjunction with. And the way to visualize this are these different layers within the data lake and the data warehouse environments. And it's really the consumption and processing layer where a lot of the heavy lifting happens. This is where the need for the data warehouse is required with your data lake, as well as a data virtualization application. So the idea is that the data warehouse and the data virtualization work together to manage and govern data and to handle business critical workloads And the purpose of the data lake is only a data storage layer of historical and metadata. So as storage prices get cheaper, your data lake just becomes the place where you store everything. The data warehouse is where you do the fine-tuning of the data. And in fact, Gartner is predicting that by 2021, 70% of mature organizations will have more data flowing from their data lake to the data warehouse than vice versa. And this is a very important statement because 5 or 6 years ago, this was not the case. The message was that it was going to be a wholesale migration of data to the data lake. So now we're seeing that the data warehouse is even more important. So the data lake still plays an important part in the analytical ecosystem. It is a great, inexpensive repository to store raw, unexplored data. Companies have made huge investments in their Hadoop infrastructure. And even though it has not panned out as originally expected, it still serves a purpose today. The modern data warehouse has stepped in to save the day, so to speak. It has opened the door to many possibilities to process, store data, and make the data available to downstream applications. The modern data warehouse makes it possible to stream terabytes of data in near real time by high-speed data extraction from any platform, whether on-premises, in the cloud, for those interactive applications that service thousands of users that demand second or sub-second response times. It enables real-time insights in order to make quick mission-critical decisions, like to enable near real-time insights like detecting fraud or CRM type events to act upon. So the consumption layer I spoke about in the previous slide allows you to offload these mission critical processes and then put it back in the data lake when you're done. This makes your data lake much more agile if you pair it with the data warehouse. So where does Yellowbrick fit in this picture? Well, Yellowbrick is an MPP data warehouse designed and architected for extreme high performance at scale. It's designed from the ground up to run complex queries against data sets with billions and trillions of rows. It is built on physical hardware from the ground up and is in reality a reinvention of the MPP data warehouse built on flash technology. The architecture is based on flash memory hardware and software developed to handle native flash memory queries. The appliance includes integrated CPU, storage, and networking, with the data moving directly from flash storage to the CPU. The system's modular design can scale up to handle petabytes of data simply by adding analytic nodes. And the Yellowbrick Data Warehouse is a modern scale-out MPP device that delivers the fastest data warehouse in the industry. And this cannot be achieved with virtual machines running on commodity hardware in a cloud environment. And as I said earlier, Yellowbrick is uniquely suited for the hybrid cloud. With Yellowbrick, you get the choice of deployment on premises, in the cloud, or a combination of the two. The Yellowbrick Cloud is based on the foundation of the all-flash data warehouse appliance. So you get the same performance on premises with the advantages of running in the cloud. And our service offers fast, low latency, high throughput connections to any of the major providers or cloud providers, including AWS, Azure, Google, with access to your favorite cloud apps and to your own data centers. So this allows you to move data to and from the cloud providers very quickly and easily. And Yellowbrick also comes with replication-based failover and failback. So in case of a disaster, you know your data is protected across the Yellowbrick cloud and on premises. So let's explore some use cases. The first one is data lake augmentation. How would you use Yellowbrick together with your data lake? In this scenario, you have a data lake that supports many formats, including Avro, Aura, Orc, Parquet, to name a few. Again, the data lake is a storage area that contains all kinds of raw data in a variety of formats that you need. With Yellowbrick, high-speed loader, that can load and unload at wire speed and comes with actually a Spark connector that can understand all of the different data formats. You can not only stream data into your data warehouse, but you can also strip off large amounts of data from your data lake so your analysts and data scientists can start analyzing it right away. Yellowbrick offers one view to the application users and the data warehouse platform. And since Yellowbrick interface is PostgreSQL compatible, analysts and analytic users do not require retraining or retooling. The data warehouse allows you to optimize your data layout with your query patterns. So if you need to do some complex queries from the data lake, you can do that with the data warehouse. And since Yellowbrick is a hybrid data warehouse, you have the flexibility to do your work on premises, in the cloud, with the option of some features from the major cloud providers in any combination. Another use case for Yellowbrick is the data lake, is the idea of a consumption zone. And it is an easy way that you can define specific functions, technology, internal business groups, and how they have access to the data. For example, your finance department may need a view to the data lake, and your sales department may need another view. Particularly for your finance and sales that usually have urgent need for data and insights, it can be a long and tedious process if you try to access that data directly in the data lake. It's much more agile if you have a data warehouse that can strip off the data that you need, and it's much easier to implement data governance and compliance per geography, which is a big concern for the large enterprises today. And with the consumption zone approach, it's also very easy to implement chargeback mechanisms. So in this example, you can charge the finance department for their usage, and the same for the sales department. So it can actually turn into a lucrative business model for your IT department. Originally, the data lake was envisioned as one single repository on one technology platform to do analysis across different data sets. But over time, the reality is, especially for the large enterprises, and due to the lack of governance and knowledge, multiple data lakes start cropping up in the enterprise. And I have heard the term Wild West to describe the Hadoop system in a few of the customers I was supporting in my previous job. Each individual business owner has their own silo with their own version of the truth, and everybody listening today knows what the result will be from that scenario. Inefficiencies, data and process redundancies, and the complexity just gets out of control. So the modern data warehouse provides a quicker time to answer, where you can have one single location for the data analysis and can do this with extreme performance at scale. With Yellowbrick Modern Data Warehouse, it can process petabytes of data with better price performance than any other data warehouse. So the data lake is your storage area containing all different types of data in a variety of formats. And the data warehouse is the intelligent consumption zone where all of the compute complexity and heavy lifting happens. So let's dive into a real case study where Yellowbrick has augmented the customer's Hadoop data lake. So one of Yellowbrick's large financial customers has a large data lake and was using MapR. This data lake was used for all of the company's business units, including risk management, credit card, fraud analysis, and customer 360. And they were finding it very difficult to get information out of the data lake at a reasonable rate. They could only process 1 month of data in order to get any kind of reasonable response. So this was not working out for them because 1 month of historical data was not enough to get useful results. So they were basically running their business on ballpark figures. The real requirement was to process 6 months to 1 year's worth of data in order to produce meaningful results. So Yellowbrick did a POC for them and demonstrated its high-speed streaming capabilities and was able to query billions and trillions of rows in sub-seconds. plus the ability to plug into their BI tool with hundreds of concurrent users for real-time dashboarding with little or no changes. The competition could not do this. Therefore, they chose Yellowbrick. So they are now using Yellowbrick for real-time dashboarding and business intelligence and taking the real-time feed that's going into the data lake and streaming it up to Yellowbrick data warehouse and offering the data to the different divisions. The benefit for this customer is they have been able to do very detailed predictive analytics and analysis, not only for their risk management, which is it's huge for financial institutions. They've also been able to get a better view of their customer behavior with pattern analysis, so they know what kind of services to offer their customers. So in summary, with their Hadoop system, they were very limited with the number of concurrent users accessing the data lake because of poor HDFS and high performance. So with the Yellowbrick, concurrency has risen to thousands of users, allowing them to do more queries with 10 times performance improvements and broader historical analysis. So Yellowbrick works with a range of industry partners to be able to solve any problem or fulfill any requirement the customer is dealing with. For example, our data, motion, and orchestration partners we work with for extracting and loading data in and out of Yellowbrick at wire speed are well-known popular ones, including Informatica, Attunity, and Denodo, to name a few. Our Postgres-compatible interface makes it very easy to integrate with popular BI and visualization tools such as Tableau, SAS, and MicroStrategy, and more. So with Yellow Cloud subscription, you get dedicated resources to ensure great performance, single tenancy, no noisy neighbor, low latency, and large bandwidth connectivity with high throughput to your favorite cloud providers and their apps. So to conclude, Yellowbrick can help your business be more successful by offering a modern data warehouse that scales to manage your largest data sets with unparalleled price performance than any other data warehouse. It makes your business more efficient by augmenting your current platforms, especially helping enterprises maintain their Hadoop investment and helping them keep up with innovation, simple, because Yellowbrick is uniquely suited for the hybrid cloud, making your migration to the cloud quick and easy. So to see what Yellowbrick can do for you, please book a demo. Just go to the Yellowbrick website at www.yellowbrick.com, and you can also follow us on Twitter and visit us at Facebook and LinkedIn. Thank you for your time today.
Thank you so much, Lorenzo. Fantastic presentation. It looks like we have time for one question from Martin Jones. Do you think that a fourth-generation data warehouse, together with ODS, Analytics Data Store, and data marts, would remove the need for much of what is stored in a data lake? Thank you for the question, Martin.
Well, based on the presentation today, the data warehouse is the best solution to be able to help out with the data lake, because the data lake gives you the possibility of, many concurrent users and be able to get, the SLAs that the enterprise requires. Any other questions?
I think that's all we have for now. We are at the end of our time anyways, but if there are any questions that you didn't submit into the Q&A, you can still do so before the end of the webinar, and we will submit them to Lorenzo. So again, Lorenzo, thank you so much. We really appreciate your time and your insights and great presentation.
Thank you. Thank you to everyone listening today.
Terrific. So we are going to go on to our second speaker now, DeMers. Hi, Dan. How's it going?
Good. How are you?
I'm well. And you're going to share your screen with us?
I am, yes.
Perfect. And I'll let you take it away.
Can you see my screen now?
Yes.
And you can now see the presentation before I jump in and embarrass myself?
Yes, you're good to go.
All right, cool. Hey, everyone. I'm Dan. I'm the CEO and co-founder of Cinchy. I'll give you a little bit of background on myself and the company. My background is working in financial services. I spent more than a decade working at some of the biggest banks in the world in IT, always building enterprise-grade systems, front office, middle office, back office. So very complicated systems that were global in nature. And that's where I met my co-founder almost 10 years ago. And we realized that the only way to dramatically simplify that was to really create a new foundation that worked very, very differently than how conventional applications work and their role in how they interact with data, which is exactly what we've done. And so we created Cinchy. We've been in the market for about 2 years now, and we've been rapidly growing and scaling the company since then. And today I'm really excited to talk to you about the idea of data fabrics and how they are very quickly now key to enabling the eventual reboot post COVID-19. So what's really interesting about this pandemic from a business perspective is it's very unique. It's unlike any prior crisis. From a business perspective, every organization on the planet suddenly needs to rationalize and reduce spending. And at the same time, though, while that's happening, everyone needs to simultaneously fast track efforts to digitize service delivery. There's not going to be any tolerance, even beyond the short-term recovery, for customers to have to go into a physical bank branch and fill out a paper-based form to apply for a loan or a mortgage. It's just not going to happen. Everyone's going to now have been used to everything becoming digital. So what that means is that the need to do more with less is way more than just an expression. It's now an existential requirement. And what that translates to is pretty much every company on the planet needs to immediately find ways to free up capacity. And the best way to do that is to unlock hidden efficiencies. Let's start by going back to 1862. Prior to the railroads, transporting people and goods was very inefficient and dangerous. The railroads were transformational in that they connected populations across vast spaces, ultimately forming a connected network. This new network unlocked compounding efficiencies and ultimately fueled the Industrial Revolution. This network continues to accelerate even today. The advancement and upgrades of rail from steam to diesel to electric to maglev and beyond. And this is just an example of the power of networks. You can look at the telephone, the power grid, the internet, and other examples. They offer similar benefits. Yet today, companies buy and build hundreds of applications to run and evolve their business. And with today's architecture, every application manages its own data store. What that means is that every project is burdened by the need to integrate and protect data. On average, this easily consumes 50% of the budget and time for every new project. This also requires the duplication of data. And as soon as you copy data, you've lost control over that data. While data fabric technology is very new, it's already proving the ability to free up this capacity. And the way that it works is by separating your data from your applications. With the data fabric, data is managed as a connected network, and new solutions can connect directly to the fabric to avoid the cost and complexity of what we call today integration. Also, by avoiding the duplication of data, the protection and control is now guaranteed. You're not doing incremental effort over and over again with every individual solution. So just like the railroads, the efficiencies are compounding as the network grows. And the response to COVID-19 has accelerated the adoption of this new technology while simultaneously laying the foundation for really our next revolution. Data fabrics utilize a network-based architecture, and this is similar in concept to how the human brain works. This is a very new approach, and it unifies data integration and data management and forms the new foundation for delivering the digital capabilities of the future. Solutions built on a fabric are far more economical, they're far quicker to deliver, and they also uniquely guarantee the protection of data privacy in ways that are just not possible with conventional approaches. So what is Cinchy? At its core, Cinchy is the world's leading data fabric. It can run in the cloud or on-prem. The core fabric provides persistence as a service, as well as data controls as a service for all new applications. And we go beyond just a base data fabric. The platform also includes a built-in data browser. Just like the web browser, the data browser provides users with a single interface to access your connected network of knowledge, not just to see it, but to touch it, feel it, change it, delete it, approve it, and even extend it. The only requirement, of course, is that you need access, and that access is maintained by the rightful owners of that data down to the cellular level, really how it should work. The platform also enables builders to create what we call data experiences. Think of that as the evolution of what we today call applications. And really what they are is they're the applications minus the complexities of data management and data integration. So it's still a rich experience. It's still specific business logic and business rules, but it's dramatically simplified by the leverage of the underlying fabric. The future of applications is actually a little more than a skin that sits atop your data fabric. When you add up these three capabilities, it really creates a new paradigm we call data collaboration. And this is a really big deal. And what excites me the most of all is how this new approach finally gives people and companies control over their data. Our customers today include some of the biggest banks in the world, large asset managers, credit unions, government agencies, and more. And they're all using Cinchy to take back control of their data and deliver net new technologies in a fraction of the time and cost versus conventional approaches. As a recent example, Concentra is a wholesale bank based out of Canada. They needed to rapidly deploy a new solution going from concept to live to enable more than 35 credit unions to deploy $400 million of small business relief for emergency loan applications for COVID-19. Thanks to the power of a data fabric and Cinchy, they took that from a concept to live accepting applications in under 1 week. The magic of a data fabric is really how it enables data to work the way it really should. Finally, users can now connect directly to the data, and the owners of data are always in control. Here are many other examples. What's interesting about these use cases, if you look at them through the lens of conventional technology, these are very different projects, very different use cases, and need very different software. But if you look at it through the lens of data collaboration, not only are there now similarities, these are actually all the same use case. It's called data collaboration. I'm actually going to show you the platform quickly in a minute. But ultimately, we're very excited about the future that this new foundation is going to enable. Please visit us at cinchy.com to find out how you can get started for your organization. And sorry, my mouse has disappeared. It's back now. I'm hoping you can now see my screen, minus the presentation. So what I'm doing now is I'm actually logged into Cinchy, and we use the platform to run and grow our business, the company of Cinchy. But what I'm actually doing now is rendering one of the built-in data experiences that allows me to experience my entire data fabric, where the only limitation is it's only showing me the data that I, Dan, have access to. So other employees in the company could easily be managing their own data sets and not granting me access to that. So that's again how you would expect it to work. But if I zoom in here, what you're seeing is all the knowledge, all the data that exists in our company. And this is something that has been built up as a result of us using the platform to deliver business capabilities over the past 2 years. So it happened iteratively where we were getting continuous value throughout that journey. But we're now at the point where I have all company knowledge accessible through a single data browser. And you can see all the different nodes of data. So there's our employees, for example, and it's larger than some of the other nodes because it's more connected. It's this mustard color because it's in the human resources domain. So now you can see our HR data fabric that has all the data that you would expect in an HR system. But what's powerful about this is side by side with our sales data domain. So what you're now seeing is our sales data network, where we have things like ARR targets and customers and leads and opportunities and all the things that you would expect in a traditional CRM type system. And all of this data is now searchable. So I can look for our leads as an example. I can locate that data set and I can go down from the satellite view to the street view, and I can then see and even change that data depending on my level of access. And I can click through on a particular name. Now I'm looking at that contact. I can go to the company. Now I'm looking at that company. I can go to the salesperson. Now I'm looking at that salesperson. All of this data is seamlessly connected in ways that are not possible with a traditional siloed approach. And not only is this enabling us to deliver new solutions in a fraction of the time, but it's creating this magical artifact of a data fabric, which is an incredibly strategic asset. I know for our company, we can implement change in hours that would typically take months. And that's ultimately what the benefit is to our customers. And that's it.
Terrific. Thank you so much, Dan. Really great work. Everything you've been doing on COVID-19 is fantastic too, and very enlightening. And we do have a question right now from Eric. You showed some compelling success stories in clients. How is Cinchy succeeding where data virtualization and other technologies have not?
Good question. So there's a lot of what I call fake news in the industry today around virtualization and its relevance to data fabric. So data virtualization is really creating what I would call a kind of the illusion of an interconnected data fabric. So the real core difference there is a data fabric is the system of record. Is as you build new solutions, you're not standing up a new data silo and then making it appear to be connected data through a virtualization technology. Is the net new data, whether it's new attributes, new entities, for new systems that you're building are now stored natively on the fabric as its operational store. It is the transactional repository. So as you're building more and more solutions, you're able to connect that data without doing any integration. Now, virtualization still plays a role. So Cinchy actually does include with built-in connectors the ability to essentially attach data from existing internal and cloud systems like Salesforce and more. And what that's really doing is creating a virtual view of your legacy data such that it's now available on the fabric. But where the fabric goes beyond that is the fact that it's now the store for new data for new systems.
Terrific. The next question comes from Dina. Are there any potential risks of data collaboration?
No. Everything has risk, but what I would say is the overall risk profile relative to data sharing, which is the legacy alternative, is exponentially smaller as a result of collaboration. So in collaborating, it's similar to if you use Google Drive to work together on a presentation. You can put it in a central location where the backups are automatic and you can manage access, not copies. And you can take that access away. And if you corrupt a version, you can go back in time. And that's all the type of benefits that you get with a collaboration platform like Cinchy, but now you're able to apply that to your actual core business data. So what that translates to is much lower risk versus the traditional approach, where if I use that working on a presentation together analogy, we're exchanging copies of that over email attachments, which is really how systems work together. They're not emailing. What they're doing is they're exchanging data over APIs and over ETLs and over data replication. It's all these other things, but ultimately they're exchanging copies, and the copies themselves. Imagine if you could copy money. So one of our core thesis is the future is one where people demand and get control over their data. And that's only possible, and this is just one example, in that future, it would be illegal to copy data in the same way that it's illegal to copy money.
Okay, awesome. Lots of questions coming in. Our next question is from Martin Jones. Dan, does it also work as a data hub between data suppliers and data consumers? And how does it integrate? How does it integrate, for example, disparate and siloed customer databases of various applications?
Yeah. So the sorry, what was the first part of the question? I got the second part.
Yeah, it's does it also work as a data hub between data suppliers and data consumers?
Yes, it does. So a data hub with persistent caching for high performance collaboration. The difference between a data hub and a data fabric is really the data hub is, think of that as a central landing zone that different people and or systems and or organizations can drop or pick up data. So you could absolutely use the fabric as the repository, but usually you want to go a little bit further now that you have the capability of, rather than just using it to facilitate the sharing of data, but you can do the direct real-time collaboration on that data live. But there's definitely scenarios where utilizing it as a data hub would make a whole lot of sense. And the, now I forgot the second part of the question.
How does it integrate?
Oh, yes. Okay. So so first of all, there's net new data, what we call autonomous data that lives natively on the fabric. But the ability to connect in existing data is obviously critical. You're not going to discard your thousands of existing systems and your existing data. You need to be able to reuse and leverage that. There's no question about that, including modern SaaS platforms where you want to unlock that data. So the platform includes a number of built-in connectors, and those connectors use a very simple config approach, and they can do real-time, they can do intraday, they can do daily, event and time-based, and they can take data from the old world, like let's say an on-prem Oracle database or an online SaaS solution, and make that data available via the fabric. But they can also reverse that flow and take data from the fabric and push it out into the legacy world. Essentially, kind of like how if you buy a new MacBook Pro that only does USB-C, you buy a dongle to hook it up to your old HDMI TV. It's the same concept, and the dongles come with the platform, but you don't have to use our dongles. You can use other kind of dongles that exist, like MuleSoft and other things that allow you to adapt in data from existing legacy silos.
Okay, and I think we have time for one more question. How well will the Cinchy platform scale up?
Yeah, so there's scaling up and there's scaling out, and one of the powers of this network-based architecture is it would be impossible if the internet was just a single network. What it actually is, and what enables the scaling, is the fact that it is a network of networks, and that's ultimately the path to scaling on the platform. And the ability to have different networks and being able to connect those networks together, initially within an organization, but ultimately even across organizations, think Internet of Data, is the path to scaling where you're able to continue to provide access, now providing copies. So it's really that network-based approach that facilitates that eventual expansion. That being said, you get started by intercepting the projects that you're already planning. So you're building out your network iteratively such that you can scale the underlying infrastructure proportionally as you grow.
Okay, and we actually, looks like we do have time for one more. What would the governance approach for ensuring, for example, GDPR compliance?
Yeah. So it's a great question, because if you look at GDPR and CCPA and all these things, those are just the tip of the iceberg. Unfortunately, governments need to limit their privacy regulation based on what's available from a technology capability perspective. So as technology makes new things possible, you're going to see those regulations kind of up the game. Ultimately, again, ending in the destination that we believe, where people get actual control over their data in the same way that you have control over your money. So things like GDPR are very, very difficult in a conventional architecture where you have siloed solutions and the right to be forgotten and all these other considerations. Well, when you have a data fabric and you're not copying data repeatedly over and over again, suddenly what used to be an impossible project is almost a trivial endeavor. Not to mention the fact that because you're not copying the data you're getting access, is a lot of those wouldn't even be needed as a compensating measure. Now, that being said, you're not going to have all of your data on the fabric with your first project. It's an iterative process. So some of our customers are actually building solutions to enable them to comply with these new regulations and leveraging the platform to accelerate that delivery to enable that on-time compliance. But while they use the solution for new solutions, including that solution, it has the privacy by design. It's built right into the platform. It's auto governance, auto privacy protection.
All right, fantastic. Well, it looks like that is all the time we have today for Dan's presentation. Dan, again, thank you so much. Fantastic presentation. Thank you so much for everyone for your questions and Dan for answering them. And thanks again.
All right, thanks.
We're going to be moving on to our last presentation of the day. We're going to be hearing from Rob from MariaDB.
Yeah,
Who's the Director of Developer Relations. Hi, Rob.
Hey, how are you?
Good. How are you? We can
Doing
hear
pretty
you.
well.
We can almost
Awesome.
see you.
Let's see if I can.
Perfect.
Can you see the screen?
Yes, we can. You are good to go.
My chair here, and I apologize for the quarantine beard. I vowed not to shave it until I can go outside. So let's go ahead and get started. My name is Rob Hedgpeth. I am the Director of Developer Relations at MariaDB. And essentially that just means that I try to improve the customer, ultimately the developer journey for using MariaDB products. So essentially an evangelist, if you will. Today I'm going to be talking about SkySQL, the ultimate MariaDB cloud. And the first question that you are going to have, I'm sure, is, what is SkySQL? But really, to understand SkySQL, we all need to get on the same page, or running at the same pace. And in order for us to do that, started pretty simple here, and I promise we'll ramp up quickly. But first, it starts with defining what a database is. And you can think of a database as a very simplistic picture or diagram that I have here. As I'm a very simple person, I like to ramp these things up. But we've got this bucket which represents our database. And this bucket can take, in our case, information. And unless we pitch that bucket or do something, it's going to persist. And that ultimately, from a very high level view, is what a database is. And if you haven't heard of MariaDB, MariaDB is a database, a SQL-based relational database that came from the beginnings of MySQL, and then in 2009 was forked and MariaDB was born. And that's really all I'll go into the history of it, because ultimately we want to understand what SkySQL is. And in order to do that, we really need to understand what a database as a service is. So I've taken the same image of this database, or the bucket, and I've overlaid that on a cloud. Now, this cloud really, it can be a cloud that you think of when you think of cloud vendors and how you can access information. But essentially, you can think of it really as an abstraction, right? That you can actually use as a service, hence database as a service, or DBaaS for short, to be able to save and store persistently files into the database. But as an abstraction for this DBaaS, it's going to eliminate certain things for us. And so we can think of SkySQL as a DBaaS for MariaDB. Now, why would you want to use a database as a service? Well, there's a lot of reasons that we could go into, but from a very high level, simplistic view, you can think of a database as a service as having to eliminate certain maybe mundane, or maybe not trivial, but kind of more boring tasks that we have to complete in order to get a database up and running, like provisioning a machine or setting up multiple machines or clusters of database, and all that really goes into the configuration, depending on whatever database you're using. Now, in this case, it's not necessarily MariaDB, but there's a lot that goes into that. And when you start to go down that path of setting up a database, you're also going to eventually hit this question of security. How is data transmitted over the wire into the database? Do I encrypt in motion? Do I encrypt at rest? How do I answer these questions? And a lot of these things will pop up for applications that you're going to be building, and there may be different answers for this. And so the DBaaS dream really is to focus on the left portion here of the screen, which is focusing on your job, right? And that doesn't necessarily have to be from an application developer's point of view, but if you're a business analyst, if you're in QA, anything that you're doing, for the most part, you want to spend as little time in the database as possible. And so a database as a service allows users to be able to have this very easy implementation, as I've shown here really with this button, in order to be able to set up a database or multiple databases. And in fact, databases as a service give you the levers and the knobs and buttons in order for you to be able to still configure some things, because as humans, and especially humans in tech, we undeniably want some version of control. And so database as a service allow you some of that control, but also abstract quite a bit of the heavy lifting. But if you're familiar with the database as a service market, you're probably wondering at this point, why SkySQL? Why now? Why do we need another database as a service? Because if we look at the industry, we know that there are a lot of players out there, and I've just put in a few. And the purpose of this session really isn't to dive into comparative reasons of why you would use MariaDB versus any other database vendor, but it's really to make the assumption that based on whatever reasoning you have, you've decided to use MariaDB as your database solution choice. But now you're probably wondering, okay, but MariaDB is already in the cloud, right? AWS has an option in RDS, and Azure Databases has the ability to be able to use MariaDB. And to be honest, they're good solutions. They're not great, which we'll get into, but from the very beginning, they're very good solutions whenever you want to get started. They allow you to be able to have that ease of use that you'd be expecting from the cloud. You can use MariaDB features that reside within community. You get the self-service and automation and a lot of the abstraction that you would expect from a database as a service. And until SkySQL, you really had two options to be able to set up MariaDB in the cloud. And the first one is being able to set up the database as a service using something like RDS or Azure Databases, and then being able to couple MariaDB subscription to get that support. The other option or other path you could take is to use infrastructure as a service. So you can think maybe EC2 and being able to more manually be able to control your databases. And then again, couple that with a MariaDB subscription for the support. And these were really the best available options until SkySQL came out. But at the beginning, it may have seemed pretty promising, but there started to be these annoyances, right? Where you're getting more watered down solutions for things like clustering or sharding of your databases. You begin to notice that the database versions, depending on which cloud provider that you're using, may be months or even years old, and they're missing crucial bug fixes, crucial features, and they're very antiquated, right? So you're not getting the latest and greatest features, like being able to use MariaDB column store to actually calculate and use within your application this idea of real-time analytics. And there's no real support, right? Because you can certainly couple on MariaDB support, but they can't actually get in and repair or provide patches for that database. And so you're actually just waiting for the next cycle of a MariaDB version to come out in order to be able to get those fixes if they come. And so what really differentiates SkySQL is if we go back to that model where we talk about using MariaDB within the cloud, we can actually categorize the usage of MariaDB before SkySQL as really using it through a third party and more of a first generation DBAS. But with SkySQL, you can think of it as purely native, as it is created and managed by the creators of MariaDB, but it's also a second generation DBAS, and the fact that it provides that on-premises reliability. You get the latest bug fixes and features provided in MariaDB Enterprise, which will always go to MariaDB Enterprise before they go to community. And then you get a lot of the aspects like full service and the expertise and experience from MariaDB that really start to differentiate, which we'll dive into a little bit more here. And when MariaDB gets control, really, of being able to provide a DBAS, then a lot of the features and a lot of the functionality that we provide within the platform hits the market much sooner in a way that's fully managed for you to be able to use, such as, being able to use expansive topologies for application tiers that may span from very small applications to Fortune 100 types of applications. You get the reliability, of course, that you would expect from a DBaaS, but you get the latest bug fixes and security updates that you would expect from a premium product. And because MariaDB are, the individual is actually creating the source, you're going to get a DBaaS that's architected and developed really by the engineers that created the database, which makes a massive difference, because then you're able to get the latest bits of functionality, such as smart transactions. And if you haven't heard of hybrid transactional analytical processing databases, it's a mouthful. I won't go into it now, but you can really think of it as combining the best of both worlds from row-based storage and column-based storage. And this really starts to create a foundation rooted in different technologies that we can actually highlight that make SkySQL above and beyond the current MariaDB cloud offerings, such as the fact that it's foundationed on Kubernetes and the Kubernetes API in order to be able to provide a fully multi-cloud supported database as a service. Within the databases, you're going to get, the latest and greatest offering of features, and most importantly, you're going to get the support that comes second to none to be able to provide those bug fixes and security patches that you would expect from, again, a premium product. And they are, again, those MariaDB experts actually working on the database code itself. And diving in a little bit into the architecture, we can see how some of this functionality really comes together. Now, at first glance, this diagram may be a little bit to take in, but we can start from the bottom, where we've got our database clusters, or our databases sitting within inside of clusters. And within each of those cloud providers, we can see that, of course, they're different services, but ultimately you can use the Kubernetes API in order to be able to communicate and manage those clusters. Above that, then, there is a SkySQL control plane, and its job is really to provide an interface for ServiceNow, which we're using for the SkySQL portal, so a web portal that you can go in and easily be able to create databases or manage your inventory and be able to create workflows that then get sent into the control plane and managed with the Kubernetes API. Taking a slight step back, it may be a little easier to digest when we look at it from this angle. And again, if we start from the very right-hand side, that's going to be very similar to the slide before, where on the bottom, we were managing those Kubernetes clusters, which contains MariaDB. And in this case, we have a firewall that basically exposes the ability for customers or developers to tie into the database. And so this is done through IP whitelisting. So you can actually connect applications and using a variety of different connectors and a variety of different languages to communicate with the underlying databases. On the very left-hand side, you can see that we have the SkySQL portal. And its job really is to be able to allow users through a web interface to create workflows and manage inventories. And those tasks then get sent to that SkySQL control panel, which actually is going to then be able to relay those Kubernetes commands into the Kubernetes cluster to manage the database. And of course, we collect all kinds of health metrics and system metrics in order to be able to relay that back to the customer in the web UI in forms of things like monitoring dashboards using Prometheus and Grafana, to being able to look at workload analysis using machine learning, which I'll get into just a little bit after this. And finally, in the direct bottom middle here, you see SkyDBAs. And those are certified database administrators that work for MariaDB that will never have direct access to your database, but instead log in through an identity proxy, and then using a jump server can help you with anything that you need to do within your database. But again, providing that level of security so that they cannot get directly inside of your database. And this is really just getting started, right? The idea of SkySQL and the architecture behind it is so that we can provide a premium offering in a way that we can also be very flexible and very scalable for the future, and being able to provide that cross-cloud. And so where we've started now is really with the Google Cloud Platform, or GCP. We've added the ability to replicate your tables, replicate databases and information inside. We have database metrics and read scaling. But in the months to come, we're going to be adding features in support for things like AWS, the ability to cluster your database environment, and looking really into this workload analysis, so that rather than just looking at read heavy or write intensive or mixed write, we can actually go a level deeper and really start to analyze the workloads that your database has, so that we can set up more guided configuration and storage scaling, and eventually get to this idea using machine learning of self-optimization and automatic scaling. And of course, be able to add things like sharding, support for Microsoft Azure, and Google Anthos. And if you'd like to know more information about how to get started with MariaDB SkySQL, you can visit mariadb.com/products/SkySQL/get started. And we are also offering a $500 credit. So it's free to get started. I would highly recommend it if you just wanted to try it out, and then you can cancel it later. But it's worth giving a shot. And we also have a variety of developer examples ranging a bunch of different ecosystems and languages, so that you can just go ahead, download those repos, and then be able to get started within a matter of minutes. And if you have any questions after this, you can email me, Twitter, or you can go and judge my code on GitHub. I am big on open source, so everything I write goes out there for better or worse. With that, thank you.
All right, thank you so much, Rob. We do have a question. Is there a limit to how many databases one can deploy?
So there's no limit to the amount of databases that you can deploy, but there are a limit of initially of 3 database services. So database services are going to be, and I briefly went over it, either transactional in nature, analytical, which is column-based, which allows you to do very similar things like you would in a data warehouse. And then this idea of setting up a hybrid transactional database service instance, which allows you to take advantage of both row-based or transactional information and analytical information. And with that, you can have 3 different services, but within inside of those database services, you can put as many databases as you need to.
Terrific. And our last question, what are some major advantages from moving to a DBAS environment? My apologies.
Yeah, and what's really great is Dan, kind of hit on this before, is that, really, I think we're starting to see that with, this pandemic now and the ability to do things remotely, or, when we don't necessarily have access to physical machines, maybe on-prem, or, being able to get access into a data center, we're starting to see that, we can function really well on the cloud, and we can function very well remotely. And I think that with a database as a service, you get that portion of it. Now, on the other side of it, and this is really more from my own experience, I come from an application development background. And so for me, I know enough from a database perspective to be dangerous, but I prefer to stay in the application code. And so a database as a service really allows me to manage a database, configure a database at a higher level, without actually having to get in and research what are the best practices for configuration, what are the best practices for security. Those are things that are abstracted away and really thought out of by the database administrators at MariaDB.
Perfect. Well, thank you so much, Rob. Fantastic presentation. Yeah, and as Rob said, his contact is there if you have any follow-up questions for him. And thank you so much to all of our speakers today for their fantastic presentations. We appreciate everyone for attending as well. And we hope that you can join us next week on Thursday, May 7th, where we're going to be discussing with speakers how organizations from startups to large organizations are navigating through the COVID-19 crisis. So thank you so much again to all of our amazing speakers and to all of our audience members, and we hope to see you all next week.